Hi everybody, it's Mrs. Dunn again. This is part 2 of the normal distribution screencast that I have created for you. In this screencast, specifically what we're going to do is we're going to be talking about calculating a z-score and using it to find the area under a normal curve. We're going to calculate the percentage of data between any two values in a normal distribution. And we're going to do this using normal distribution tables and our TI-84 graphing calculator, which I have up here and ready to go. All right, so here we go. So we've talked about the normal distribution in the previous screencast, but to recap, you want to make sure you remember that that normal distribution has a normal curve, that's how we describe it, and it's a bell curve, and the mean, the mode, the median is in the middle. And when we have a standard distribution, that mean, mode, and median is all zero. We'll see that in the next few examples. You'll also want to remember that we measure how far we are from the mean in terms of standard deviations. So remember we had the z-scores from the screencast that hopefully you just finished watching. And in this, we calculate a z-score, which shows us how far we are in terms of standard deviations from the mean. And the formula for finding that z-score, which we used in the previous screencast, is we take the piece of data, subtract the mean from it, and divide by the standard deviation. Okay, so now what we're going to do is we're going to begin by using the chart, and we're going to find the area under the normal curve using the chart. So determine the area under the normal curve to the left of z equals negative 1.00. We're going to be using these charts, which give us the table of the areas to the left of z. Now in this chart, I give you z values that are negative. And in the other chart, you have z values that are positive. You see this list of positive. Okay, now let me show you how this is going to be done. We want to find the area under the normal curve to the left of negative 1. That area is 0.1587. Now I'm going to show you how to do that. First of all, there's something you need to understand. In a normal curve, the area under this curve is equal to 1. 1 is the biggest that answer that you could possibly get. 0 would be the smallest answer. Okay, so that's the answer for what the area is equal to. So we want to find the area to the left of the z-score, which is negative 1. So what we're going to do is we're going to look in our chart at negative 1.00. That number is 0.1587. It's circled here in green. So the area to the left of negative 1.00 is 0.1587, and we found that in the chart. Now, I'm going to take it one step further because we're going to be doing this later in this screencast. That means that 15.87% of all the data is to the left of z equals negative 1.00. You'll see we've taken that 0.1587 and changed that to a percent. And 15.87% of the data is to the left of negative 1.00. Okay, let's do another example. Oh, actually, first, let's do it on the calculator. Okay. So to do it on the calculator, first of all, you're going to have to access the normal distribution menu. And that's going to be under this DISTR menu. So to access that, we press second and vars to access that DISTR menu. So that gets you to here. Now we're going to use the normal CDF menu. Normal CDF. You'll see that highlighted here. So press enter. On the newer calculators, you're going to have a wizard like this. And the calculator makes it easy for you to put in these values. If you have an older calculator, it might just say normal CDF at this point, and you're actually going to have to put these values in here. Okay, so this is asking for a lower value, an upper value, the mean, and the standard deviation, and we're going to plug that in. So I want to go back to this previous screen because I want to show you something. So when it's asking us for the lower value, it's asking for this value over here. Well, this goes on forever and ever and ever. If you remember from algebra, maybe you had like a pre-calculus course or something. This is like asymptotic, which means this line is going to come and get really close to this horizontal axis, but never actually get there. So the lower value is actually something really small. So let's say it's like negative 9,999, a really, really, really small number. The upper value is negative 1. So we're going to put negative 1. That's that z-score. The mean in this case is, since this is a standard curve, the mean is 0 and the standard deviation is 1. So I want to go forward in the screencast so you'll see. That's where we got these values. I see before I recorded this, I actually put negative 99,999. It doesn't really matter. You need something really small, but I'll go ahead and make it the same so that you're not confused. And you just press enter. And like I said, when you press enter, it's going to look like this on your calculator screen. And it's the same thing for those of you with an older calculator. The difference is that you have to put these numbers in. So you'll actually put negative 99999 in parentheses on this screen instead of a screen that looks like this. But it's the same thing. Press enter once all that information is in there. And you get the same area of 0.15865. So 0.1587 was rounded. It's really easy to do on the calculator. Okay, let's go through another example. So the second one, we were asked to find the area to the left of 1.19. If we're doing it using the chart, we have to go to 1.19 in the chart. So the first two digits are 1.1. So I'm going to go to the row that starts with 1.1. And then it's 1.19. So I'm going to go all the way over to here. It's circled in green. It's 0.8830. So the area to the left of 1.19 is 0.8830. And this is how we do it on our calculator. So we're going to press second vars for the distribution menu. Make sure you use normal CDF and not PDF. We're going to use the CDF function. We'll press enter. The lower value is still negative 99999, and the upper value is 1.19. That's the z-score to the right of the area we're looking for. Press enter. If you have an older calculator, you put those numbers in. Press enter, and you'll see how we get 0.88297. If we round that, it's 0.8830. Excellent. I really think the calculator is the easiest way to do these. You have the technology. You paid for it. If it was me, I would use it. All right, next thing we want to do is look at the area to the right of z equals 1.19. Well, if you'll remember, those charts give you the area to the left. So if you're going to use the chart, it's going to give you this area of 0.8830. We have to be smart enough to realize that we have to subtract that from 1. Remember, the total area is 1. So 1 minus 0.8830 gives me the part that's to the right, which is 0.1170. Now, if we're doing that on the calculator, once again, press second distribution, normal CDF, and the value to the lower value, that lower value, the area, the value to the left is actually 1.19. So we'll put 1.19 there. We want the area to the right, remember? So the lower z-value is 1.19. And now we need a really big value. So we'll put like a value like 9,999. I put 99,999. I actually put an extra 9 there. But anyway, so we want a value that's really, really big. Plug that in. Press enter. Once again, if you have an older calculator, you type those numbers in and you'll get the same area of 0.1170. That means 11.7% of the data is in this shaded region, which is above 1.19. Okay, the next example, we're going to find the area between two z-values, negative 1.62 and 2.57. Now, this is really going to be complicated if you're doing it using the charts. So if you're using the charts, you need to find the area to the left of negative 1.62 first. So negative 1.62 is 0.0526. Then you're going to have to find the area to the left of 2.57. 2.57 is 0.9949. So now we have the area to the left of negative 1.62 and the area to the left of 2.57. And what we have to do is subtract those. So here's the area to the left of 2.57, the area to the left of negative 1.62. We subtract those to get the area in the middle. So remember, here's the whole area, and then we're going to take out that part that's to the left of 1.62. So it looks like this. Way easier to do on the calculator. So on the calculator, we go to our distribution wizard, normal CDF function. The lower value in this case is negative 1.62. The upper value is 2.57. So we're finding the area between these two values. Press enter, and you get the answer of 0.9423 when we round it. It's pretty easy, huh? All right, now, what if we are given information and we are not told the z-scores? What I strongly recommend is you draw a picture of the information that you have. If you're going to be using the tables, you're going to have to change the scores you're given to a z-score like we did in the previous screencast. But you don't have to do that if you're using the calculator. I'm going to show you mostly how to do it on the calculator. I really do feel that's the best way to do it. So we're going to go through these three examples. So here's a practical example of how you're using this information. In these normal distributions, it's normally distributed but not standard. And what I mean by non-standard is the mean isn't 0. So look, for example, IQ scores are normally distributed with a mean of 100 and a standard deviation of 15. Determine the percent of individuals with IQ scores. We're going to do 3 examples. And the first one we'll do below 115, above 120, and between 75 and 115. I strongly recommend that you draw this picture first. The first one we're doing is finding the percent of individuals with IQ scores below 115. If you change 115 to a z-score, it becomes 1. So we need the area to the left of 1. If you're using the chart, you look in the chart and you'll get 0.8433, or I'm sorry, 0.8413. And so change that to a percent, and it's 84.13%. On the calculator, once again, we go to that distribution menu in normal CDF, And we're going to put these actual scores in our calculator. We want the area or the percent below 115. So once again, we need a number way over here, a value way to the left. So I'm going to put that really small value of negative 9,999. The upper value is, well, if we're using a standard distribution, it would be 1. But we can just put this number 115 in here. The mean in this example is 100, so we can change this to 100. And the standard deviation is 15. See, what I'm trying to point out here is on the calculator, you don't have to use z-scores. You can skip that step. You don't have to find the z-scores. You could just plug the information that you have in your calculator and let the calculator calculate it for you. And so you end up with the same answer. Now we have to remember that this answer is in decimal form and you have to change it to percent form to get the answer. And it's 84.13%. I feel like it's way easier on the calculator. If you have an older calculator, you're going to put down the lower value, the upper value, the mean, and the standard deviation in that order. Okay, let's look at the next one. In the next example, we want the area, or I'm sorry, the percent of individuals with IQ scores above 120. The z-score is 1.33. You're going to have to do 1 minus the area to the left of 1.33 if you're doing it using the chart. But on the calculator, we'll go to the distribution menu in the CDF function. The lower value is actually 120. The upper value is a really, really big number, like 9,999. The mean is still 100. Standard deviation is 15. And plug that into your calculator. Press enter. And the area to the left, area to the right is 0.0912. When we change that to a percent, it's 9.1% of all individuals have an IQ above 120. Okay, one more example. The area between 75 and 115. So what percent of all individuals have an IQ between 75 and 115? You have to go through that really long process if you're using the z-scores. Way easier if you're using the calculator. So second distribution, CDF. The lower score is 75. The upper score is 115. Make sure your mean and your standard deviation are correct. Just paste that in your calculator and you're done in like 3 seconds. 79.3%, 36% of all individuals have an IQ between 75 and 115. Okay, that's all there is to it. I really encourage you to use your calculator to do these problems. It's so much easier. Good luck. Email me if you have any questions.